Now we are on population distribution. So first we have clump distribution, which is some separate groups but are randomly spread out. The resources are unevenly distributed and there's a positive interaction. Then there's uniform distribution, which are all individual and equally spaced out. Food and water are scarce and there's a negative interaction. And then there's random distribution, where they're very randomly spaced apart and mostly individual. Resources are evenly distributed and it is a neutral interaction. So the characteristics of population. So determining population size and density. Population size, or the big letter N, is the number of individuals of the same species living in a specific geographic area. And there's population density, which is D with a little p, number of individuals per unit of volume/area. How can we measure populations? There's transects and quadrants, I believe. So transects are samples taken from a long rectangular line of a specific length. The starting point is determined randomly. Researchers walk along a determined length, counting individuals a certain distance away from the line. And then there's quadrats, which are an area of specific size is used, best for sessile organisms such as plants. The number of individuals within the boundary is counted. For the quadrat calculations, it's dp, or population density, equals n over a, so sum of individuals over total area. And then there's a mark recapture. So it is not possible to count some types of species, especially because of their movements. In this case, track, nests, burrows, and scats can be used to estimate numbers. Other populations with mark recapture animals are caught, tagged, and released. Later on, traps are set up again and scientists compare the proportion of marked to unmarked animals. So N equals the number of originally marked times the total in recapture over marked individuals in recapture, or N equals mxn over m. Big N equals big M times little n over little m. Fecundity is the average number of offspring produced by a female over her lifetime and represents an output of energy. It varies between species. Animals that reproduce and die often have large numbers of offspring, so high fecundity, and animals that survive often care for their young for many years, which have a low fecundity. Fecundity is also affected by age at which an organism becomes sexually mature. Survivorship is the proportion of organisms that live to a given age within a population. There are 3 types. Type 3, so most individuals die as juveniles, often before they are born. A large number of young are produced to compensate, example, salmon. And there's type 1, which is opposite of 3. There's a high rate of juvenile survival. Individuals live beyond when their young are born. Young are well cared for, so example would be human. And then there's type 2, which is between 1 and 3. The risk of mortality is constant with the organism's lifetime. Density-dependent factors are abiotic events that affect population growth in the same way regardless of population density. Examples are floods, droughts, forest fires, hurricanes, tornadoes, other violent storms, and extreme cold or hot weather. Density-dependent factors are biotic events that affect population growth and density. Example would be competition for food, water, mates, shelter, sunlight, predation, or spread of disease or parasites in a population. That's why social distancing was important during COVID-19. Intraspecific competition is a competition within a species. Example, coyotes compete with other coyotes for food, like rabbits. And then interspecific competition is competition between species. So coyotes competing with foxes for food or rabbits. A predator-prey relationship is a type of density-dependent factor that controls population size. So the predator chasing the prey, eating it, and maintaining the population. And if the predator becomes too much, then the prey will go down, affecting the population, and vice versa. Biotic potential is the highest possible per capita growth rate for a population. Factors that affect biotic potential include number of offspring per reproductive cycle, number of offspring that survive long enough to reproduce, age of reproductive maturity, number of times individuals reproduce in a lifespan, and lifespan of individuals. There's an exponential growth curve where the population has no limits. It's a lag followed by rapid exponential growth. There's no predation. Resources are unlimited. The graph is J-shaped and is often found in labs. Example, bacteria, small invertebrates, invasive species, and humans. Carrying capacity is the maximum population size that a habitat can sustain over an extended period of time. There's a graph for that, which is there are a few individuals in the population, so growth is slow. Next is a period of rapid growth. Resources eventually become limited and competition starts. Growth of a population slows. Birth and death rate become equal. Graph is sigmoidal S shape, so a sideways S kind of. growth can also be referred to as logistic. An example would be any creature with a predator-prey relationship and large mammals. Now we have R and K strategies. So the R selected strategies are used by organisms that live close to their biotic potential. They have short lifespans, mature sexually at a young age, produce large numbers of offspring, and don't spend much time caring for their offspring. Example is insects, annual plants, and algae. Then we have K selected strategies, which are used by organisms that live close to the carrying capacity of their habitats. They have longer lifespans, mature sexually at an older age, produce fewer offspring, and provide lots of care to their young. Example is mammoths or birds. Then we have immigration versus emigration. So immigration is the movement into a population. Emigration is the movement out of a population. Birth is natality. Death is mortality, which are the four processes that influence population change. A population explosion is when there's a rapid increase in individuals, like with invasive species, and a population crash is when many individuals die rapidly, like during extinction. GR stands for growth rate. Triangle N stands for change in population. So the original population minus the new population, and then the triangle T means the change in time. So the equation for per capita growth rate is CGR, capita growth rate, triangle N, so change in population size, over N1, the new population, and then times 100%, so you get the percentage of the per capita growth rate. So demography, this is human population growth. Demography is the study of statistics related to human population, such as size, density, distribution, movement, births, and deaths. The factors that helped human population grow is improved agriculture techniques, domestication of animals, testing for illness, better shelter for mother, improved food storage. Doubling time is the time it takes for a population number to double. Population pyramid is a type of bar graph that shows age distribution in a population. So in developing countries, the pyramid is more fat, like triangular shaped, fat going to skinny at the top. This is because there are more offspring per female and healthcare is not as good, so people don't live as long. And then in developed countries, it's kind of like a straight, skinny thing with like different levels. This is because it's the opposite of developing countries. There's lower birth rate and more elderly people. Available biocapacity is the Earth's carrying capacity for human population. Factors included are cropland, grazing land, fishing grounds, forest land, carbon absorption land, and building area. So now we're going to talk about species interaction. So some defense mechanisms to avoid predation are thorns, quills, toxins, protective coloration. Protective coloration includes camouflage, body coloration as a warning signal, and mimicry. Batesian mimicry is when a species has coloration to look like another species that happens to be dangerous to predators. So examples are poison dart frogs, stick bugs, etc. Symbiosis is an ecological relationship between two species living in direct contact with each other. So there are three: parasitism, mutualism, and commensalism. Okay, so parasitism is when one organism benefits and the other is harmed. Example, a tick feeding a dog.